Hello everyone, hope you are doing well. Welcome to the online platform Civil Technobricks. Guys, here we will tune for instantaneous decoding of conceptual knowledge in the field of civil engineering where study elaborates decoding the earth to build a better world. Today we will go through the core concepts related to the Indian remote sensing satellite programs, their evaluation, sensor technologies and applications. Guys, the Indian remote sensing program was initiated by Indian Space Research Organization, that is ISRO, to provide reliable satellite data for natural resource management and national development. The Indian remote sensing satellites, which support mapping, monitoring, and assessment of land, water, vegetation, and infrastructural resources which are available on the Earth's surface with reference to its curvature. The vision point of view, the National Natural Resource Management System, that is NNRMS. That program also represents India's transition towards self-reliance in Earth observation technology. In civil engineering domain, Indian remote sensing data is extensively used for urban planning, watershed management, transportation studies, and environmental monitoring. With reference to that vision point of view, to support the natural national natural resource management system by providing systematic, repetitive, and reliable data based on some space segment, ground segment, and user segment. The primary goal is only that we have to complete the survey and management of the vegetative material like agricultural, geological material beneath to the earth surface, hydrological parameters which are available with reference to the valley portions, and the coastal ecosystems related to the ocean and catchment areas of any type of dam. So the main principle or objective of the Indian remote sensing is the mission is to use the satellite data for the survey purpose and management purpose for the natural resources. Here, the evolution of Indian remote sensing technology point of view, we see that the root, that is generation 1, the trunk, that is generation 2, and now we have n number of satellites. The Indian remote sensing technology evolved from modern resolution imaging systems to advanced high resolution Earth observation satellites. Successive generation introduce improvements in spatial, spectral, radiometric, and temporal resolutions. These sensor capabilities expanded from basic resource mapping to detailed infrastructure and environmental analysis. These technological advancements, which are most useful and enhance the accuracy and efficiency with reference to the traditional to the advancement of civil engineering investigations and GIS applications. So the generation 1, this is the base, that is the root. Generation 2 will be the trunk of a tree like structure, and these all are the branches, that is Resourcesat, Cartosat, Oceansat, and RISAT. The RISAT is the radar point of view. Oceansat, which is useful for the marine and its characteristics. Cartosat is useful for urban planning and mapping, whereas the Resourcesat, which is for the agricultural and its investigation point of view, we can use that technologies. With reference to Indian remote sensing 1A and Indian remote sensing 1B point of view, they are the pioneers, where 1A was the India's first operational remote sensing satellite that mark a major milestone in India's Earth observation. It carried LISS-I and LISS-II sensors for land resource monitoring and mapping applications. The satellite provided valuable information for agricultural, forestry, and water resource assessment. Civil engineers use that 1A data for land use mapping, site selection, and regional development point of view. The spectral bands which are used, that is 4 bands with reference to the color blue, green, red, and near infrared. This technology, which is most useful for the repetitive cycle of 22 days of data collection. The satellites are in the orbit of near polar sun synchronous satellite, which having the altitude of 904 km. IRS 1B, or we can say that IRS 1C and 1D, that Indian remote sensing 1B, which enhanced data continuity and improved optical resource monitoring capabilities. The satellite which is maintain similar sensor systems while increasing data reliability and coverage. With reference to Indian remote sensing satellite 1C and 1D point of view, they are introduced the pan cameras capable for providing high resolution imagery. That additional sensors such as AWiFS and LISS-III, which improves multispectral observation capabilities. These satellites enable detailed mapping and better identification of engineering features. The most important application which are included with reference to the high resolution revolution 1C and 1D, they are more useful for highway alignment purpose, urban planning and utility mapping with reference to the project monitoring. The steps and the steer means we are using the satellites that is for the Nadiri view also and that is for the oblique view also. With reference to that, we integrate our accuracy and resolution by taking the stereo images. Indian remote sensing P series, that Indian remote sensing P series which is based on the prototype to specialization. The P series leverage the polar satellite launch vehicle, that is PSLV, to bridge the gap between experimental payloads and dedicated thematic missions. So what is the P theory? That is P1, P2, P3, P4, P5 up to P6. Likewise, P1 and P2 that are the development flights. P3 which is the MOS payload which is on the base of the German technology. P4 which is of the Oceansat 1 that is for the oceanography. P5 which is on for the Cartosat 1 that is for the cartography and terrain modeling. And last one P6 that is the Resourcesat 1 that is for the advanced agricultural point of view. So this prototype to specialization which enhances the Indian remote sensing and its domain with reference to its advanced technologies and data collection point of view. Resourcesat series, that is the agricultural watchdog basically, which ensuring the data continuity for the green revolution with integrated land and water management for the LISS-IV, LISS-III and AWiFS likewise. So Resourcesat satellites were specifically designed for resource management and sustainable development. Advanced LISS and FS sensors provide the spatial resolution and wider coverage of the area. The satellites supported large-scale land use and land cover mapping activities. For civil engineer point of view, that Resourcesat data is more useful for watershed planning and for accurate cartographic and environmental impact studies. Then Cartosat series of mapping the third dimension. The Cartosat satellites provide very high resolution imagery for accurate cartographic and engineering applications. The stereo imaging capabilities enable generation of digital elevation models and the terrain models or terrain informations. These Cartosat satellites support detailed topographic mapping and infrastructural planning also. This civil engineering point of view, we can use that for road design, bridge projects point of view, route alignment and mapping along with the urban infrastructural development. The Oceansat series, that is IRS P4, which is useful for monitoring the blue frontier. That Oceansat satellites focus on the oceanographic and coastal environmental monitoring, where sensors measure ocean color, wind speed, sea surface characteristics for just like the hurricanes point of view or some disaster point of view. Data supports that for coastal zone management and marine resource assessment, where civil engineers use that Oceansat information for coastal infrastructure planning, docks and harbor construction and their development, and shoreline management activities, where ocean color monitor and microwave radiometer, these are the two spectral bands basically used for data collection point of view or assessment point of view. Ocean color monitor 8 spectral bands, where microwave radiometer have the multispectral scanning. Then RISAT series, that is radar imaging technology which sensing through the clouds, so there will not be any barrier of the cloud for the data collection. The optical sensors are blended by monsoon clouds, so that RISAT uses active radar to monitor floods and agricultural year round. So RISAT satellites, that is synthetic aperture radar technology, for all weather and day night imaging point of view we can use the data. Radar sensors can penetrate cloud cover and provide reliable observations during adverse conditions. That RISAT is particularly useful during floods, cyclones and emergency situations, where the civil engineering applications that include that the flood mapping, landslide monitoring, disaster assessment and terrain analysis purposes, where the passive and active, active synthetic aperture radar, which is based on the C band, which directly penetrate the pulses and return that pulses to detect it. At the same time, the passive optical, which is blocked due to the sun rays, which is the only source of light used passively, so that the obstacles of the cloud will block the actual view, which is explained. So RISAT, which is an active synthetic aperture radar, which penetrates that pulse through that clouds, so there will not be any obstacle of cloud to data collect. The physics behind that, that is sensor technology basically, that is the evolution. Push broom scanning to the cosine law. Indian remote sensing sensors evolved from modern resolution spectral systems to high spectral optical and radar technologies, or we can say that the high resolution purposes, which improve the spatial and spectral resolution, which enhance feature identification and classification. The stereo imaging or the radar imaging expanded three-dimensional terrain analysis and its capabilities. These advancements, which improves the engineering surveys, resource mapping and infrastructural monitoring and its accuracy with reference to the civil engineering and its surveying activity. Based on some data products and GIS integration point of view, that is the progression of spatial resolution, the transition from regional resource management to precise urban infrastructural planning, that is Cartosat 1, then 1C PAN, then IRS 1C, LISS-III, IRS 1A, LISS-II, IRS 1A, LISS-I. Likewise, the altitudes are changing with reference to the length or with reference to the height point of view. Indian remote satellite generates raster datasets, thematic maps, digital elevation models, and geospatial products. These datasets can be directly integrated into GIS platforms for analysis and decision making process. The application point of view in civil engineering, GIS, which more useful to integrate efficient management of spatial and attribute information, that civil engineers use these products or technologies for suitability of site, analysis of site, transportation planning, utility management. Likewise, so case study point of view also we can use it for the municipal corporation of Hyderabad. Just like the case study, we can see the layer by layer raster based land use classification road network vector. What will be the outcome for it? That is used for green belt identification, urban sprawl monitoring and drainage alignment point of view. Means that remote sensing information which is assist you as an engineer in watershed management, groundwater exploration and floodplain mapping. Urban planners use that inner remote sensing imagery for land use analysis, smart city development. Disaster management point of view, that agencies are utilize that data for hazard mapping and emergency response planning also. On the global context, Indian remote sensing versus Landsat versus Spot, that is the actual comparative phenomenon which are explained. With reference to that, we see the importance of that each and every satellite system. The Indian remote sensing bridged the gap of offering the high revisit of weather satellites with the spatial resolution of spy satellites. Just for the heritage standard, the hybrid point of view, the commercial rival point of view, the resolutions are different. 30-meter for Landsat, resolutions for India's IRS, that is 5.8, that is the pan cameras are used, and where spot resolution 10-meter pan cameras are used. Likewise, the strength, spectral coverage, high revisit plus high resolution and off nadir viewing. Likewise, the global context point of view, each and every satellite program have its mission and goal. It is working for the same and collecting the data or sorting the data for the agencies. The future trends for Indian remote sensing technology point of view, we see that future Indian remote sensing missions focus on higher spatial resolution, which improve revisit frequency and advanced sensor systems. They are also working for the integration of optical, thermal, hyperspectral, and radar technologies for Earth observation capabilities. Nowadays, the AI and GIS, which are integratively work to improve the automatic feature extraction and monitoring purposes. These all developments will provide civil engineers the faster, more accurate and real-time geospatial information. Indian remote sensing program has evolved from basic resource observation satellites to advanced higher resolution Earth observation systems. The technology evolution has enhanced mapping accuracy, terrain analysis, environmental monitoring and disaster management. means that satellites play a crucial role in planning, design, construction, monitoring, and sustainable engineering infrastructural development point of view. Stay tuned, guys. Happy learning.